As I promised you, we are going to solve problems related to a uniformly accelerated motion. So, solving problems. I'm going to read the problem and I'm going to take the given during the and identifying the required during reading. A car is increasing its speed from 25 meters per second to 31 meters per second. So the initial velocity is 25 meters per second. The final velocity is 31. So V equal 31 meters per second. So we have the initial velocity and the final velocity with a uniform acceleration of 1.8 meter per second square. So we have a constant acceleration 1.8 meter per second squared. How far does it travel while accelerating? He's asking for how far does it travel while accelerating, so he's asking for the displacement. We have equations of motion. Which equation we are going to use? You can write all the equations aside and you can pick whatever suitable for your answer. We can solve this by two methods, the short method or the long method. So we can use one equation to reach the result, or we can use two equations to reach the result. I'm going to solve it with the first method and the second method. Here is the first method. We are going to use the third equation, or whatever the number of the equation, v squared minus u squared equal to as. So s is equal to v squared minus u squared divided by 2a. So what is the final velocity? 31 squared minus initial velocity 25 squared divided by 2 times 1.8. What is the result? It's 93 meters. You have to write it in two significant figures. Since the initial velocity is too significant, the final velocity or the given data is in two significant figures, so the result should be with the same significant figure, two significant figures, whatever the value. We can use it by another method, as I told you. Here is the second method. We can find the time first. V is equal to u plus at by using the first equation. The final velocity is 31 equals to the initial velocity is 25 plus a is 1.8, and we have t, so I'm going to move u to the left hand side. I'm going to change the sign. So 31 minus 25 is equal to 1.8t. 31 minus 25 will give us 6 equal 1.8t. So time is approximately equal to 6 over 1.8 equals 3.0 seconds. And we are going to calculate the displacement by using this equation. S is equal to ut plus half at squared. The initial velocity is 25, the time is 3 plus half, the acceleration is 1.8, by the time is 3 squared. You will find that the value is about also 93 meters. So we have two methods for calculating the displacement covered if we have an object moving with constant acceleration. Let's move to another problem. If the examiner is saying that we have the average acceleration of a sprinter from the time of leaving the blocks to reaching her maximum speed of 9 meters per second. So leaving the blocks, it means the initial velocity is 0. So the initial velocity equal 0 till it reaches 9.0 meter per second. So the final velocity is 9.0 meter per second. Is 6 meter per second square. So the acceleration is equal to 6.0 meter per second squared. For how long does she accelerate? Is asking for the time. For how long does she accelerate? What distance does she cover in this time? And then he's asking for the time. We are going to use the same method we did before. So for finding the time, we are going to use the first equation. V is equal to u plus at. V is 9 minus u, which is 0, is equal to a, which is 6, multiplied by t. So t is equal to 9 over 6, which is 1.5 seconds. So the time is 1.5 seconds. For calculating the distance covered, or the displacement covered, we are going to use the second equation is equal ut plus half at squared. U is 0, so this factor is 0, so we have half times the acceleration, which is 6 multiplied by the time, which is 1.5 squared. You will find the result as 6.8. You have to put it into significant figures. Don't forget to put the unit after the value. Okay, we are going to solve past paper later, so I'm going to stop solving but we applied for the simple, for the movement of an object with a uniformly acceleration or a uniform acceleration. Okay, I want to explain something here. In the method of calculating the acceleration, if we are going to have a graph, and this graph is between displacement time graph. So if we have a displacement and the squared of time, and the graph is represented by a straight line, what do you think the gradient will be? Some students will thought that the gradient is the acceleration, but actually the gradient here is not the acceleration. In order to calculate the acceleration, we need to draw the largest graph, the largest triangle. So rise over run, here we will have the change in the displacement, and here we will have the change in time squared. Since the object starts motion from rest, and we are going to use this equation, S is equal to ut plus half at squared, because here is the relation, that linkage between displacement and the square of time. Of course, the object starts motion from rest, so the initial velocity is 0, so 0 times t, whatever, it will give us 0. So S is equal to at squared divided by 2. So if we are going to calculate the acceleration is equal to 2s over t squared. If we are going to find the gradient will give us s over t squared. So in order to calculate the acceleration from displacement squared of time graph, we are going to multiply 2 by the gradient, or 2 times g will give us the acceleration, and the unit of the acceleration is meter per second squared, or whatever, meter per second squared. Since the displacement is in meter and the time is in second, since we have t squared, we have s squared. Okay guys, so we finish with a hint. It will help you in solving past papers. Okay, until I meet you again, I wish you all